And let's jump in. And first, we're going to talk about why we love stainless steel. And so, whenever possible, we are providing stainless steel with our systems. That goes for the pumps, which are 304 stainless steel, that offers maximum corrosion resistance for the external metal pieces of the pumps. And then we also like to provide stainless steel for all of our fittings here. And so, we actually have um, right here we have a stainless steel well seal. And this is a custom design that we made up because we just couldn't find anything on the open market. A lot of these other fittings we can find. We actually manufacture all our own fittings to optimize cost, because we find once we manufacture our own fittings or our own well seals, we can get that price down to what a comparable plastic or cast iron fitting or galvanized fitting would cost. And so by going direct to manufacturing these cells, we're able to pass those savings on to you, so you don't have to spend the expensive amounts that a lot of the other places are charging for the stainless steel fittings. And so this is our stainless steel well seal. This is our biggest one we have. This is an 8-inch one. We have a lot of different sizes here. We have our 8-inch here. We got our 6, our 5-inch, and our 4-inch. And this is the only stainless steel well seal available on the market. And we developed this ourselves because we couldn't find an alternative, and we wanted to provide stainless steel with all of our fittings and all of our kits. And so, but why do we want stainless steel is a common question there. There's cast iron, there's galvanized, and then there's plastic for a lot of these fittings and for our well seals. But stainless steel provides the ultimate corrosion resistance. So all of these fittings and these parts are going into a very harsh environment, whether you have different water chemistry that might be a little more challenging. Maybe it's acidic, maybe it's basic, dissolved solids, iron, bacteria. All of those things down in the well and up above are very challenging for a lot of metals, including cast iron, galvanized, and plastic. And so whenever we can, which is basically all of the parts, we like to switch those over to stainless steel for maximum lifetime. We want these pumps and these parts to outlast you. Instead of a 5 or 10-year lifespan, we want a 20, 30, 40-year lifespan. Basically, we want you to be able to pass this on to your kids, because that stainless steel is going to sit there out in the environment. It's not going to rust. It's not going to corrode. It's just going to be real resistant to all those harsh elements. And so some people might be asking here, depending on where you're located in the country, you might be like, hey, what is a well seal? I've never seen a well seal before. And that's going to be very dependent on your climate. And so if you're in a freezing environment, you're going to be more accustomed to a well cap and a pitless adapter, which we'll talk about in a little bit. But if you're in a warmer where you don't get hard freezes, then you're going to be much more accustomed to a well seal, just because they're a little bit easier to use, easier to install, because they sit right on top of that well casing. So if we pan down over here, we have our demo well, and you can see this is what it looks like if you have a well seal. The seal is sitting on the top of our well casing. The outside rim here is holding everything up, and it's pushing all that load down against the well casing. There, I can pull up here a little bit, and you can see it's not very deep. We can do it with one hand. So all of that weight is going from the top plate to this well casing, so nothing falls down. It all hangs from our poly pipe here. And then we have all our stainless steel fittings up and through. Then at the end of the day, everything's being held up by that top plate. And so that's another reason we like stainless steel as opposed to plastic. We just have concerns with plastic and hanging all that weight on it over time. We don't want anything to crack or to morph, to move around like that. We know if we're putting in a metal top plate there, a metal well seal, it's going to hold that for years and years, especially when you may have 100, 200, 300 pounds hanging off there. But like I said, it's going to be temperature dependent for your environment. And so as you can see up on top there, there's a lot of exposed metal fittings. And so if you get soft freezes, you're not getting hard frost, you're not getting snow on the ground for extended amounts of time, you can go with the well seal and just insulate that. You go down to the hardware and get that insulated kind of tape foam that you can wrap around all of that, just to help prevent that hard freeze from entering in there, sealing it up, and possibly causing an overpressurization of your system when that pump kicks on, but there's ice in the line and you can't push it out. So a little bit, I kind of showed how this goes together, but you can see this is our 1.25 inch well seal. This one is 5 inches in diameter. 5 inches is down below here. The top plate's a little bit larger, so it sits right in our casing. So this main hole is where we're putting our through fittings. They're a little challenging to get in here because we do have that sanitary seal. All right. So the sanitary seal is this rubber piece, and this is required by some municipalities based on code. They want to make sure at the top of the well casing, there's a nice seal there, because you can take this, you can tighten these 4 bolts up. It's going to compress that rubber, and that rubber is going to seal against our well casing. It's going to seal against this pipe. And a lot of times, if you're going to use conduit, it's also going to do a seal right here where our wire is going to go through. And so they call it a sanitary seal because we don't want to contaminate our groundwater. We don't want things entering down the well casing that are then going to leach out into our groundwater. So a lot of places require this by code, the sanitary seal. A lot of times it's not really needed. You can see over here, that one I did with the well is not tightened up. And I can come over and show you. It works just fine without tightening it. And I could feel it as I go down. It's a little bit of friction as I lower it down there. That's sealing it well enough. And so a lot of times, me personally, I don't recommend tightening these bolts because over time, out in the environment, this rubber with the heat and the cooling can start to harden a little bit. It lasts years and years, but it can harden. And you really don't want this getting stuck on top of your well casing because then you're gonna have to go cut around your well casing in order to pull this whole thing off and get it out. So when I do installations, I just get it very lightly snug so I can still pull it up and down, but I can definitely feel that the rubber is contacting the inside of the well casing, providing that sanitary seal. So little bugs, any water, anything doesn't go back down our casing and then get into our water supply. So you can see we have our through nipple here. That's this part. Again, this is 1.25 inches. We go through here. All of these stainless steel well seals that we have are 1.25 inches. We find that's just a very universal size. It's good for some irrigation. It's good for household. And if you have a smaller system, you're only doing a few gallons a minute, it's really easy to adapt this up and down to whether we're doing a 3/4 inch or a 1 inch fitting. And that larger hole there won't cause any problems. So it's just easier to use 1.25 inches on everything and then use some of these other plumbing fittings in order to adapt to a larger or smaller diameter pipe. Here, we'd like to put a T on top. The T provides a lot of different options. We also use this plug up here because a lot of times we don't have any use for this top hole on our T, but it's nice to have. If you ever want to put a pressure gauge there because you're using a pressure system, you can add that in this port. Also, if you're pumping, say, up a large hill and you can't see where the water's going, you can always unscrew this to see and make sure you have water pumping out, up and out of here versus always having to run up to our tank to check if it's pumping into a tank. So it's helpful when you're first setting up to make sure, hey, that pump's turned on, water's shooting out of here. Great, I'll seal this up. Probably won't have to access it again. And then from this side of the T, I can take it off and go to whatever I want. Whether I'm adapting to, say, a flexible poly pipe that I'm going to go along the ground or underground with, or whether I'm going to adapt to a PVC or steel pipe to take that off to my tank. So this is for the top of the well seal. Now at the bottom here, we need to get to our drop pipe. And if you watch any of our videos, if you follow our website, we really like the black flexible poly pipe. This is the only plastic we recommend to use in the system. It's weather resistant, UV resistant, plus it's going to be down on the well. And so nothing's going to happen to this pipe down the well. This just makes the installation so much easier than using a plastic PVC or a steel pipe. If they made stainless steel flexible pipe, we'd definitely be recommending that. They just don't make it. It'd be too expensive. And so this is the one area where we do go with a plastic type of pipe, but very reliable. These are thick wall. This is 160 PSI. Sometimes we use 250 PSI. That's going to hold all of the weight from the pump, the wire, and everything else going up. And we just don't have any problems with it. They're very reliable. But we do need to adapt to that. And so here's how we make that connection. In this case, we're going to be using 1 inch poly pipe. That's what I have over here. And so to go from the 1.25 inches, we're going to use our 1.25 inches to 1 inch reducing coupler. So that's super easy to screw on here. If you're using rigid pipes, or you're using 1 inch PVC pipe, no problem. You can screw it right in the bottom of there to make your connection. We are using the poly pipe, and so we're going to throw on one of these extended barbs. I'll talk a lot about the barbs in a couple of minutes. This is the extended one. The nice thing about the extended is you can put plenty of hose clamps on here. Got 1, 2, 3 hose clamps. A lot of these barbs only fit 2 hose clamps. That's perfectly fine. I've never seen a failure of 2 hose clamps on a normal size barb, but we got a lot of requests. People just felt a little bit more comfortable on some of the deep installations where they're holding all that weight to get the extended barb plus a couple of hose clamps on there. So we went ahead, we made in some of our selection these extended barbs. We can put an extra hose clamp on there just for a little bit more assurance, a little bit more confidence in that system.
We have a question.
Yeah.
Question from Sergio. He's wondering what's the longest distance you can use this poly pipe to install a well pump. He said as well as about 1,400 feet.
Yeah, so if you're going 1,400 feet vertical, unfortunately, that's going to be on the capability of this poly pipe. So 160 PSI poly pipe, which is our most common, will go up to around 300 feet of vertical lift. Once we go beyond that, we can go to the 250 PSI poly pipe, and that's going to go to around 500 feet of vertical lift. And then past the 500 feet, you really need to start looking at like a Schedule 120 PVC. Those come in 20-foot sections with threaded ends. And so with the threaded ends, you can either use a coupler or some have a bell end. And the bell end just allows you to connect a piece of PVC to another piece of PVC without any glued fittings, any other fittings. So that's going to be your most common. Once you get beyond around 600 feet with plastic pipe, unfortunately, you are going to have to switch over to galvanized steel pipe. And then that's going to be good up to your 1,400, 1,500 feet. And that's just due to all that pressure, all that weight. We just need stronger materials than the poly pipe can do. So unfortunately, that you need a little bit of specialized equipment. If you have a hoist truck or you're willing to make some sort of A-frame, it's going to be doable to install that by yourself. If you don't have that equipment, you might want to reach out to a friend or somebody else who has it to come help out with those deeper installs. But up to 300 feet, absolutely DIY. You can go out there with a couple buddies and get the poly pipe down in a weekend and have your whole pump system up and running. Over here, we have a cast iron. So we have these stainless steel in our most common sizes, the 4, 5, 6, and 8. When we go down to a 3-inch, we just don't do many of these. And so we're still using cast iron for the 3-inch, but this is what a cast iron would look like. This is a split cast iron. No big deal. It is painted. We can see this paint over time starts flaking. It starts to rust. Not the end of the world, but just not going to last as long as our stainless steel out there in the environment.
And what sort of lifespan can people sort of expect from those cast iron belts?
Yeah, cast iron, we're looking, it's still going to be a long time. We're still looking at 10 to 20 years before things start to seize up, before you go out there and try to change your pump and you can't get the bolts off because everything's rusted in place. 20 years, 30 years sort of thing. We're really looking at the stainless steel basically for a lifetime. It's just not going to corrode. It's not going to change. These are stainless steel bolts, stainless steel top plate, stainless steel bottom plate, and a stainless steel vent plug. And so nothing to rust here. And so what I did mention is our through hole here. That's great. That's where our plumbing fittings go through. I did mention a little bit earlier, right here is where a wire goes through. It's also, it's made for either a round wire or a flat jacket, which is very common with flat jacket submersible pump cable. There is a threading here. This is, I believe this is a 3/4 inch NPT. And so that's going to allow your 3/4 inch conduit if you want to do a nice waterproof connection. So a lot of times people will bring their wire, whether it's from our solar pump controller or an AC wire, underground, and then they'll come up along with a PVC conduit and then tie it in there so their wire shielded from the environment. I'll be honest with you, a lot of our installations just have the wire coming out of here. It is PVC dual jacketed. We also just don't see problems with that sitting out in the sun, but you would want to protect it from, say, livestock, cattle, anything coming up to munch on that. Also, over here's our vent. This is optional. If you are pumping a lot of water and you're getting drawdown, you can create a bit of a suction as you're trying to suck air down in the well. Most of the time, if we're pumping at a low gallons per minute, 3 to 5, you can get enough airflow through our wire hole here or around that it's not going to be a problem. But if you do hear hissing, sounds like there's air being sucked in here, you can open up this vent. A lot of times with this, we'll take, again, another piece of like PVC pipe here. make a little up and over elbow just to prevent rain and other things from flying in there straight down. Great. So that is the gist of what a well seal is if you're in a more moderate climate. If you have any questions, we got a break. The train's coming by, but we'll get to your questions right after this train passes. Okay, maybe we got a question. Yeah. The long one.
What type of seal would be used in a shallow well setup? How does installation differ from a normal drilled well?
Yeah, a shallow well setup, a lot of times that's where we're less than around 30 feet of pumping head. A lot of times more around like 25 feet up to 30 feet. And with those, we don't have to put a pump down at the bottom of the well to push the water up and out. In those cases, since it's shallower, we're able to put a pipe down and suck the water out. There are also cases where down at the bottom, if you're a little bit deeper beyond 30 feet, we'd use a Venturi valve. That allows us to go beyond that kind of 25, 30-foot range. And that requires a lot of times two lines going down. So you need the line where you're pushing the water down and then the line where the water's coming up and out. There are specialized well seals for those. We can get them for you and custom order them. We just don't do a lot of those. And so if you're doing more of a suction where you're doing a single line, you can still use one of these fittings. So you can do all the same through fittings and make sure you seal them up really well. And then down at the bottom, we'll get to in a little bit, you're going to have to put a check valve down there. And then you're going to be able to suck the water up and out. And so with that, you can use a standard well seal. If you are doing one with a Venturi and you have two going down, then they do make specialized well seals. Not as common, but they're going to have, say, for a 6-inch size here, they're going to have a 1-inch hole and a 1-inch hole. And that's going to be your input and your output line. So there are specialized options if you're doing something different and sucking the water out or using your Venturi. Great.
We are answering any questions you have about solar pumping today. It doesn't have to do with stainless steel strictly. If you have questions about other things aside from this hardware we're seeing, feel free to drop them in the Q&A box.
Cool. Let's jump into a well cap. And so some of you, this might look a lot more familiar. If you're in a colder environment, you're not going to have this well seal in your pipe coming out of the top of the well. What you're going to have is this well cap. And this is going to cover the top. This one doesn't have a sanitary seal. Like I said, it's optional in a lot of locations. And like I said, too, is just having this on top prevents basically all of the debris, all of the water, anything from dripping in there. So we're perfectly happy with this. This is just to note, even though this is all about stainless steel today, this is aluminum. Right now, we just don't have high enough volume of these going out the door to justify manufacturing this in stainless steel, but we are looking at it in the future because we love stainless steel. We want to swap it all over. But again, here we're using aluminum. Two things about this. One is it's not holding any weight. So we don't have hundreds of pounds on this aluminum top plate holding it up because, as I show you in a second, we have a stainless steel pitless adapter down below the ground that's going to do all that for us. All this is doing is acting as a cover on top of our well casing. And then it has this little recess that allows our wire to go, our pump wire to go up and out here. And then this hole here, we can put a conduit in, metal or plastic, to help protect that wire. So that's all this is doing, is acting as a very simple cover to our well casing and then giving us a place for the wire to come up and over. And so again, colder environments, this is what you're seeing. You might not have heard this before, but some people think that the water is actually going up, over, and down, and that's not the case here. That's the conduit or the electrical conduit for the pump cable. Because we're in a colder environment, we need to let the water exit the well casing below the frost line. If we go up and over the top, that's going to hard freeze, and you're going to be out of water because all that water is going to freeze in your line. And so the magic of what we do down below the ground is called the pitless adapter. If you've never seen one of these before, it's probably because you've never had to replace it and dig out below the side of your well casing. But this is how the water is coming up from our well. It makes a right-hand turn here and then goes out the side of the well casing below the frost line. So in order to install this, once we have our well drilled and the casing installed, then we need to dig down next to our well casing below the frost line. A lot of places, you can look that up online, but a lot of places it's anywhere 3 to 5 feet, depending on how cold you get year round. And then once we're below the frost line, we can run our pipe underground and we don't have to worry about freezing because it just doesn't get that cold down in the ground. So in order to install this, we have 2 different pieces here, and they look pretty funny, but this one, which is going through our well casing. So after we've drilled our well and installed the casing, then we dig down below, and we need to drill a hole through the side of our well casing for this to go and water to flow out the side. So once we've drilled that hole, cut that hole in the side here, and we have charts online to tell you the exact size you need to drill with a hole saw. From the inside out, which makes it a little challenging. So this is our well casing. We're on the inside. We have to go and push this through. And then once we have it through, we use these other gaskets and stainless steel parts to clamp it all against that well casing. So that's going to be clamped to the side of our well casing here, all the way through, just sitting there. And what that provides is that through hole out the side of our well casing. It also has all these gaskets to prevent water from coming back in the side and down our well casing. And here you can see it's internally threaded. I believe this is 1.25 inch thread here. And so then we can go with our 1.25 inch pipe, or we could also adapt down to something smaller if we want to go with, say, a 1-inch pipe out. This is a plug, but you can see perfectly threaded. So whatever pipe or any other fitting you're going in there can thread right in to at the side of the well casing. And so the next part of this is part 1 on the edge of the casing. Part 2 is what's actually holding everything up. Let me loosen this up so we can just see it. Oh, I got this. So this is the removable part of our pitless adapter here. And so you can see it's threaded on the top, but this side's blocked off. No water can flow up and through this. The bottom side here is where water can flow up, make a right-hand turn, and then flow out the side of our well casing. And so very easy. We'll do something like this. We're going with 1-inch poly pipe and a pitless adapter. We'll put our barb on there. We'll attach our poly pipe. And then the trick is on the top here, it's threaded. And so we're going to take a piece of other pipe, preferably steel pipe, and we're going to make a little T-handle with it. And then we're going to be able to take this. We're going to be able to go over the top of our well casing and lower it down that 4 or 5 feet and have it latch in. So you can imagine, I push all my pipe down the well. Then this is coming. I have a big handle on top here, pushing it down. Then it's going to start to sit here. I'm going to get it over there and it's fitting. And then it's just slide into place. There's a gasket there for a nice waterproof, pressure resistant connection. Slides into place. Now, as that water comes up, it's going to go up through here and out the side of our well casing, down below the frost line to prevent that line from freezing. These are a little trickier to install, but very doable. Once you get this drilled on the side and create your little T-handle so you can be up above the well, lowering this all down, super easy. You can get this dropped down and installed. This is going to hold all of the weight from the entire system. And so that's going to be the pipe, the pump, the wire. It's all going to be off of this. This can hold hundreds, thousands of pounds on the edge of it. Again, you might not have seen one like this. Whether you've never seen one before or you're used to the brass ones. Brass ones are fine, but we, again, love the stainless steel. They're not going to corrode. They're not going to get any damage down in that well casing. So a little harder to find. We love these. We manufacture these ourselves. These are stainless steel pitless adapter. This is an 1.25 inch size. We also have 1-inch sizes, depending on the amount of flow you need to flow out the side of your well casing. Great. Before we move on to stainless steel fittings, any questions about a pitless adapter? this is kind of a unique one that some people might not have seen before if you're not in a colder environment, or if you are in a colder environment and haven't actually looked down in the well or seen somebody pull this thing out.
Any other install questions too?
Sure. Any other install questions or anything coming up about your application? Great. If there's no questions, let's move on to stainless steel fittings. We have an entire assortment through here. I'm going to go through real quick just to talk about some of the applications, what these things are, just so when you start piecing your system together, it kind of makes sense. You'll start to figure out, oh, I need to reduce this down to a smaller. I'll use a bushing for that. Maybe I'll use a reducing coupler. Let's talk about all these different. So first off, we have our stainless steel check valve. Again, if you're used to these, you probably see them a lot in brass. This one's 100% stainless steel. This is a spring-loaded stainless steel check valve for inline application. So if you're doing a pressure system, then, oh, we got a question.
Yeah, we have one question from Adobe. How do you get that inside portion of that adapter that goes down through the casing attached if it's 4 feet down the casing? He's talking about the piece that you actually attach to the casing set.
Oh yeah, that's a challenge. So the way you do that is great question. It's a challenging one because you got to get down. The way you do that is with that O-ring, there's enough friction here. When you put your T-handle on this, you can lift this whole thing up. Pretend this is our T-handle. We can lift this whole thing up, lower it down our casing, and push this through the side, tighten it all down, and then pull this up and pull your inside fitting back out. And so no problem there. You want to be a little careful. You want to make sure this all stays attached before you start pulling anything up, and make sure you have this through the casing with the nut on this other side before you start pulling it up, to make sure like that nothing drops down your well. But otherwise, there's no weight on it. At this point, when you're installing this, you obviously don't have any pipe, anything else on here. It's just using this top to lower it down the well casing, get it through the side, and with a buddy, how to quickly get over there and put the nut on there. There are other creative ways I've seen. In the future, we're going to do a video on this. I've seen somebody who put a rope down through the hole and then just fed this through on the rope, and it kind of swung down and went right in the side of the well casing. So other creative ways. Be careful with that rope, tie it off so you don't actually drop it, and so this falls down your well casing.
Yeah, and you will have that trench drilled so you can watch from the other side to make sure that you actually get it in the right place.
Absolutely. So there's a trench off to the other side, somebody down there, you're lowering it down, they get a stick or their finger, kind of help you get it through there, quickly get these other parts on, and then tighten it down. It's a 2-person job, takes a little finesse, but very doable. 20, 30 minutes, you can have this whole thing installed. But a great question. That's probably, for installing a pitless adapter, that's probably the most challenging part, is just getting this through the side of the well casing. Everything else is pretty straightforward. Bring a flashlight. It can get a little dark when you're looking down there 5 feet. But just should try to get this all lined up. Great. So like I was saying, a spring-loaded inline stainless steel check valve here. You can see there's an arrow. Water in this side. When the water comes in, it pushes that up. When the water stops flowing, that spring pushes it back down and prevents water from flowing back this way. This is required if you're doing a pressurized system. All of our other systems, this is optional. Most of our pumps, most of our solar pumps are self-draining. So that means there is no check valve, and the water, once that pump shuts off, is very slowly drained back down the well. We prefer that in a lot of applications, especially colder environments, because we can worry less about the water freezing in that pipe. If you're using a self-draining system into, say, an open discharge, just going into a big storage tank or a stock tank, people in colder climates will still use a well seal just because it's so easy to use if they know it's self-draining and they make sure all that water gets back down. But if you are doing a pressurized system, obviously you need to keep that water in the line, so you need to put a check valve there. Some of the pumps do have a built-in check valve. That's to prevent from a centrifugal pump spinning backwards. We do recommend, if you're doing a pressurized system with one of those pumps, you also install an external check valve on here. Again, stainless steel, super reliable. This is a little different than if you are used to a swing style. Those are for above ground applications where they don't have to go to the well. They're a bit larger here. The check valve internal part instead swings back and forth versus being spring loaded. But for your well pump applications, this is what we want. Somebody talked about drawing water out. This is what's called a foot valve. Basically, a foot valve is a check valve with a little filter on the end here. So very similar to a check valve. This is actually a check valve. We just add a filter on the end here. And this is made for mostly surface pumps when you're sucking the water out of, say, a pond, a lake, a river, whatever your water supply is. This helps filter the water coming in so we don't get large debris or anything into our check valve or into our pump to clog it up. The other thing this does is it prevents the water from flowing back and out our suction pipe. So with these surface pumps, a lot of them, even the self-priming ones, need some sort of water in there to prime. And so with the foot valve on there, we're going to keep the water in our suction hose and in our pump, and so that water doesn't run out and we don't lose our prime. Especially important on ones that are not self-priming. The ones that are self-priming, you can probably get away without using this, but I definitely install it so you don't run into issues of prime on your pump. Great, super easy. Those are stainless steel check valves. Next, we're going to move on to this nice assortment we hear of stainless steel barbs. And so this is kind of one of the most important parts of our plumbing fixtures because this is what's adapting when we use our poly pipe to go from the pump, which might have a 3/4 inch, 1 inch, or 1.25 inch. Some of our larger pumps have 1.5 inch to 2 inch, even 3 inch. This is what's adapting from that threaded fitting up to our barb to go to our flexible poly pipe, which makes these installations so much easier. We have a huge assortment of sizes. This is a 3/4 inch to 3/4 inch standard length. This has room for 2 hose clamps. Again, these are great. I've never seen one pull off. They're very sharp ridges. Once you push one of these in, you're not getting it out. If I push one of these in, I need to redo it. I cut the pipe off, split it down here. Once it's in, it's just not coming off. Once you put these 2 hose clamps, nothing's moving there. And so for shorter installs, perfectly fine. We use them all the time, thousands of these to hold from our pipe up to our poly pipe. Again, very similar. This is a 3/4 inch to 1 inch. This is a 1 inch to 3/4 inch, the exact opposite. As you can see, every time somebody's asking for a different type of hose bar because they want to go from this pump to that poly pipe or from that poly pipe to this pipe fitting, we just make a different size fitting to make that as easy as possible. The ways we used to do it is we used to call them Frankenstein fittings. You take a coupler, you take a reducing bushing, you add that all together in order to get to your final barb length. But we find we really like, since these are the critical parts, one piece if possible to go from the threads to that barb. 1 inch to 3/4 inch. This is 1.25 inch to 1 inch. 1.25 inch to 1.25 inch. All of these, I should note, if you're in the plumbing trade, these are called IPS, which is iron pipe standard. That means we're going off of the inside diameter of the pipe, very similar to how PVC pipe is. You have to be a little bit careful when you start looking at PEX, because a PEX pipe is what's called a CTS. That's a copper pipe standard, and that's going more off the outside diameter. And so it can get really confusing when you're trying to couple a PEX pipe to these stainless steel fittings because everything's off and they just don't fit right. So again, this is an iron pipe standard fitting. All of the poly pipe we supply and all of the poly pipe design for the well industry is going to be that IPS, which is inside diameter of the pipe. We use these for years and years and years and never had any problems with it, but we did get requests of, hey, I talked to this well guy and he says, oh, I only use extended barbs. While we've never seen problems with it, we're like, yeah, sure, we'll make some extended barbs. So this is a 1 inch to 1 inch extended barb, the longest one we've ever seen. If you're holding a lot of weight there, if you just feel more comfortable, you can add as many hose clamps as you want. We usually send it with 3. I've seen people use 4 or 5. Again, a peace of mind, whatever helps you sleep better at night. If you want to use this long one with a bunch of hose clamps, we're fully in support of it, which is why we designed all these. This is, what is this, 1.25 inch to 1 inch. A lot of times with an 1.25 inch pump, you're going to use an outlet pump. You're going to use the outlet's 1.25 inch. You're going to use an 1.25 inch bushing. Then you're going to go to like a 1 inch barb. We eliminate all that, go straight from 1.25 inch to our 1 inch barb. This is 1.25 to 1.25 extended, plenty of length there. We thought we were getting a little out of hand with how long some of these are. We shortened this up a little tiny bit there. What is this one? I think this one is 1.5 to 1.5. Not as common. Once we get past the 1.25 poly pipe, sometimes we switch over to rigid pipe for those larger installations, but we still use some 1.5 poly pipe. And so this 1.5 to 1.5. And then our biggest one here, I'm not even sure. I think this is a 2-inch to 2-inch. Again, not very common, but some people have the 2-inch poly pipe. They want to use that for high flows. Maybe we're doing 50, 100 gallons a minute. And we're going to use our 2-inch pipe in our 2-inch adapter here. That's the gist of all these stainless steel fittings. Basically, any of these thread sizes to any of the barbs we can make work. A lot of times we have a single barb that can do it. Other times we'll use a coupler or other adapter to make it. Just some other various fittings. I think everybody's familiar with these. This is a stainless steel T. 1 in, 2 out. We use that, like I mentioned earlier, if you didn't see that, on top of our well seals. We like that because we get that extra port there. If we ever want to use it for another application, check what's going on down in there. It's a 1-inch elbow in stainless steel. Sometimes people will use that for this top. They might not want the T, or this is what they have, so they just use an elbow up here because they just want to go up and out with their water perfectly fine. Hundreds of those out in the field. It's a 1-inch nipple. This comes in really handy. Anytime we might want to couple like 2 female to 2 female parts, we can use this one to adapt over. I don't think I have another, oh, here. So I'll say like whatever, we're using a check valve here. We'd use a nipple because it's female to female. So we use that pipe nipple in between to make that connection. This one's not as common, but a great part. This is inch, I think it was a 1-inch street elbow. So the difference between a standard elbow and a street elbow is you have male thread on one side, female on the other side. So when you're doing a connection there, you don't have to do your pipe nipple like I just showed you. You can go straight from a female over to another female without an extra part in between. Very strong, very reliable. Like that better a lot of times than putting that nipple in between when we're doing the right angles here. So again, this is a right angle street elbow, which is just different than a standard. Cool. Any questions on all those fittings? That's kind of the gist. I love the plumbing. I like solving that puzzle of, hey, I have my turnkey kit, which is going to give me a 1-inch outlet on the top of my well casing. Now I need to go up to my tank. I like that challenge of how I'm going to get from there, maybe down underground, adapt to a flexible pipe, and get it off to our tank using all these various parts.
We have one question.
Oh, awesome.
Do we use pipe dope or PTFE or Teflon tape when we're actually making these connections?
Yeah, great question, great timely question, because the next thing we're going into is Teflon tape and how to seal these up. So I've talked about all the benefits of these stainless steel fittings. There is one con. There is one thing that's a little more challenging that we have to deal with that I think personally is worth it, but just takes a little extra work. And so, and see these threads here, they're machined in and they're very sharp. And what we have is stainless steel is a very hard material, harder than our galvanized pipe, and definitely a lot harder than, say, a copper or brass pipe. And so when we're sealing up a copper and brass pipe and we make these connections, the threads are a little malleable. And the malleable means that as we thread them together, they're going to deform slightly. And in this case, the deforming a little bit is actually helpful because it allows them to mesh better and to close up those small gaps in between our thread. With our stainless steel, since it's so hard, it just doesn't do that as much. And so we need to be a little bit more careful about how we're going to seal this up to make those water and pressure-proof connections. So a couple of options here. The most common, what you're going to be used to, is this Teflon tape. Really thin, sold in all the stores. You probably get like 50 feet on one of these rolls, maybe 25 feet on one of these rolls. This one is a 1/2 inch wide. And so when we do these connections, we got to use a lot of this tape. As you can see, even as I put it on, it kind of like cuts through it. It's pretty thin here. And so when I do these, I'll do a lot. I'll do like 10 wraps around, sometimes more if I'm going back and forth. this has been used throughout the water industry forever. It works. You just have to be a lot more careful with this. Really, really make sure you wrap this up here. You can notice I'm wrapping in the right direction. So this tail end is going to be on the opposite side of how I'm going to screw it in. So I twist this like I'm threading in a pipe, righty-tighty, lefty-loosey, and really thread this on here. Because we need a lot of extra tape with this to help seal it up. The question was about pipe dope. And so another option is, I think it's like the T 2 plus T or the Rector seal. It's great stuff. A lot of that has Teflon embedded into it. The Teflon is a benefit because as we thread it, it's going to lube. It's also, it's going to seal the cracks in between the threads, but it also lubricates those threads so we can get it even tighter to close up those gaps even more. So that Teflon helps prevent the friction in any galling between these two connections as we thread it to get a tighter, more waterproof seal. So it actually has two functions. The pipe dope also operates very similarly. And so that comes down to preferences. If you go read online, plumbers forums, they like to argue all day about which one's better and whether you use pipe dope, whether you should use Teflon tape, or then you get the wild card out there who's like, oh no, I use both. I use Teflon tape on the male side, pipe dope on the female side, get the best of both worlds. You're gonna have to try it out and just see what works for you. I've had some stubborn connections where I got frustrated and I used both. I used Teflon tape on one side, pipe dope on the other. It solved it in that case. Other times I've used just pipe dope and I've had a little like pin hairline or pin holes leaking on higher pressure systems. I undid those, add on Teflon tape. For me, I tend to go with the Teflon tape just from experience. And if I have a really tricky one that I just can't get right, I'll do the Teflon tape and I'll do the pipe dope. But my first start is always with Teflon tape. So this is the white Teflon tape, very universal. You can read on the package all the different things this is used for, whether you're doing plastic pipe. Again, people argue back and forth whether you should use on plastic pipe, but it says in the package, plastic pipe, metal pipe, stainless steel, but not ideal for stainless steel. So we've used this for years, but like I said, it's a little more troublesome to get this to seal up. And so we always love to listen to our customers here at RPS, and that was a common complaint. It was a very common, like, hey, I can't get these stainless steel fittings to seal up. And so we went and developed this tape specially designed for stainless steel. So again, this is good for any of this. We can use on all metal pipe joints, safe for propane, butane, natural gas. Just don't go over 1500 PSI. And we want to use at least 3 wraps of this instead of the 10 or 12 wraps of the other one. You can see this is actually a gray tape to help signify it's designed for stainless steel. This is 3/4 inch wide and what does it say? 4 mils thick. And so that's the thickness. And that's about 4 times thicker than this other tape. It's really hard to see. But if you can definitely feel the difference on the thickness between the two of them. So it's wider, it's thicker, and it's designed for stainless steel. And so it's going to help increase the lubrication between those two parts. It's also going to help seal up all those cracks to prevent any leaking from those trickier installs, especially when we have pressurized system. If you're in a non-pressurized system, open discharge, a few drips here or there isn't going to cause any problems. But with it pressurized, we want to make sure it's all sealed up so we're not constantly cycling that pump due to a leak. So we love this tape. It's the longest roll you'll ever get. It's 1,530 inches long. That's over 127 feet of tape on this. I like to make the joke is none of our customers have ever seen the inside of the roll. They've never seen the spindle there, just because it's such a long roll. Basically, it's a lifetime for most people of tape that they're going to need. Great. Any other questions?
None so far.
Cool.
I think we've gone through most of the hardware that we have today.
Yep.
So we can open it up to whatever questions you might have, whether they're related to hardware or not.
For sure. Any questions about solar pumps, water pumps, AC, pressurized system? Happy to answer those with any extra time we have here.
We talk about underwater wire connections.
Oh, great question. Underwater wire connections. If you missed our webinar about 3 weeks ago, we went through the installation of a complete solar pump, the one you're actually looking at right over here. And in that video, I demonstrated, really quickly how we're going to do those waterproof connections. But the gist is, what we want to achieve with those is, like you're saying, a waterproof splice. And so we're going to have, I don't have the parts here, but we're going to have a wire coming in this side from our pump. And then we're going to have a wire coming on this side from our drop cable, our drop wire, that's going up and out of the well. And actually, we found one right here. So we're going to take those two wires and we need to splice them together. It's not common to solder these connections. Some people do it, but it's not common. The most common way is using a splice kit, which you can see here. This comes with all of our pump kits. You don't have to buy this separate. Super easy to use. It takes about 10 minutes to install. And I'll get these out of here. So first off, we have our butt splices. We love the seamless butt splices, so much easier. So we're going to take this. We're going to put this on one side of the wire and the other side of the wire. And then using our crimping tool, we're going to crimp this on the wire. Most of you have done that before, crimping a splice onto a wire. Oh, we're going to grab that real quick. We actually have, it's still here from our install. So down below, if you have any of these, you might have a dedicated crimping tool. You might just have these wire strippers. These funny bumps down below, if you're not familiar with them, those are for splicing. Those are for doing these butt splicing. So the wire is going to go in there. We're going to see, maybe we can squeeze it down. Oh. Okay, you're going to squeeze it down. That closes it up and crimps that on the wire. We're going to do that on both sides. That's going to make a great, strong connection. Once you've done that, you should be able to pull on it. It's not going to come out of there. On the outside of that, and make sure you put this on before you do that crimp, we're going to do our internal shrink tube. Solar pumps, we use an inside shrink tube and an outside shrink tube. That's just not as common in the AC pump market. In the AC pump market, they're going to use just an outside, a little bit thicker shrink tube, and then they're going to wrap that whole thing in this electrical tape here. That's just how the well guys do it. We're doing the same thing as them. But for our solar pumps, much more common that we're going to use our inside shrink tubing and then this big outside shrink tubing for the whole cable. And this is what's called adhesive line shrink tubing. So inside of that, it's really hard to see, but it's glossy, and there's actually hot melt glue, a style of hot melt glue. So as you heat this and shrink it down, the glue is going to melt, and then as that shrink tubing compresses, it's going to squeeze out all the air and only leave that hot melt glue around the wire. It's going to bond to the wire, to the insulation and to the crimp. And that's going to prevent any water from coming in the edges because there's nowhere for that water to go. It's kind of glued on, hot melt glued to it. So this is the inside one. Same thing for our outside sleeve. Again, this is adhesive lined. You put this over the whole thing with a butane torch, a heat gun, whatever heat source you have. You can heat it and very slowly work your way down. And again, that glue is going to melt, squeeze out the end, and give us a nice waterproof connection. But like I mentioned, if you are doing an AC pump, you're going to get the outside shrink tubing. And then you're also going to use some electrical tape, seal that whole thing up. For the outside really provides a lot of abrasion resistance, not as important for sealing that wire up. What we like to say with our solar pumps, that's the hardest part of the installation. And so if you've ever done a crimp before, if you ever used shrink tubing before, you're ahead of the game. If you haven't, don't worry. We have videos on it. Our user manual is very detailed on how to do that connection.
All right, we have about 6-7 minutes left, so time for one more question before we wrap up.
Great. While we're waiting for that question, I do want to mention, thank you for joining us today. We have a special gift for you if you stuck around this long to learn about all of our stainless hardware. We have a coupon code Field Day 50. That's Field Day, all capital 50. That's going to give you $50 off your complete water pump or solar pump setup. If you're not ordering online, you're going through our pump sizers, just mention that, hey, I heard on the webinar there's a discount. They're all aware of this. They'll tack that on because we want to say thank you to everybody joining us today to learn about these great systems. By doing this, you're going to be ahead of the game when you start your installation. All of this is going to be familiar when you start pulling these parts out of that box. Great. I think that's it for the questions. So like I mentioned, this is the first of 4 webinars we're doing in September. Super excited to bring all this material to you. On our YouTube channel, we do have tons of videos on installs, applications, different types of pumps. Basically, we have an install video or an overview video for every solar pump that we offer and all the AC pumps. And so check those out. What we're doing in this webinar is we're doing more specialized discussion about various components. This one is about stainless steel hardware. The next one is going to be about pressure tanks. We're going to feature a bladder pressure tank, and then we're also going to talk about just pressure systems in general. That's a little bit more of an advanced topic when we're designing our solar pumps for that. Super common in AC pumps, but when you get into solar pumps, just a few more considerations we need to take into account in our upfront planning. So we're going to go over all of those for you in the next webinar. That's going to be next Wednesday, and you'll be getting an email about it, or give us a call or shoot us a note for the link and the exact time. And so really appreciate everybody joining us today. Super excited to kick off the September series of the virtual field day install and discussion. Really appreciate all the questions we got today. If you have any more questions that we didn't get to, or as soon as, what happens to me is as soon as this ends, something's gonna pop into your head, shoot us a note, send us an email, or give us a call at 888-637-4493. We have a team of excellent pump sizers, and that's what they do all day, is they just talk to customers about their application. What do they want to pump from? Where do they want that water to go? Whether you want to use a solar pump for it, an AC pump, whatever your application, submersible pumps, surface pumps, any of those, we can help out with one. And they're just going to walk you through the steps. They're going to just ask you about your setup, try to gather as much information as you know. For parts that you don't know, they're going to point you in the right direction and say, hey, can you go grab this information? Can you go measure your well casing diameter? Those are super common things to get sent off. Go figure that out. We'll follow up and help size and get that perfect system for you for your exact application. So again, Mike with RPS Solar Pumps, really appreciate you joining us today. And really look forward to getting the magic of these solar pumps out in the field, into your hands, pumping day in and day out without the use of AC power. Appreciate it, and goodbye.